In order to get started with number 1 here, we're going to want to draw a right triangle. The right angle has to be C, otherwise the other two angles either one can be A or B. Just want to set it up somehow. Now they tell us that side A is 8 units, side A is opposite angle A, so this one here would be A, which is 8, and they tell us side B is 7. They want us to find the sine of angle A. In order to do that, we're going to need to have the hypotenuse. So use the Pythagorean Theorem in order to find the value of C. So we'll do a squared plus b squared equals c squared. In this case, 8 squared plus 7 squared equals c squared. When you have the 64 and 49, you end up with 113 for c squared. So c would be the square root of 113. Now the sine of angle A will equal the side opposite angle A, which would be side A, so 8 over the hypotenuse, which is the square root of 113. Of course, we can't leave it like that. We have to rationalize the denominator. That ends up being 8 square roots of 113 over 113. And you would, of course, reduce if you could, but you can't, so we'll leave it like that. For number 2 here, we're going to also need to draw a right triangle. In this case, they give us side A and side C. If I stick with the same arrangement of my angles, side A is here again, and side C would be here. Now they're looking for the cotangent of angle A. Cotangent uses the opposite and the adjacent. Specifically, cotangent of some angle theta is equal to the adjacent over the opposite. Again, it's the reciprocal of the tangent, which is opposite over adjacent, so adjacent over opposite for the cotangent. So we really need to find the value of b in order to have that adjacent side that we need. So in this case, 4 squared plus b squared would equal 9 squared. It ends up, once we subtract, that b squared is 65. So b is equal to the square root of 65. Again, the cotangent being adjacent over opposite would be the square root of 65 over the 4. Here we're going to write the function in terms of its cofunction. So for number 3, we have the cosecant of 19 degrees. So again, the way that works is the cofunction for the cosecant is just the secant. Again, it's different than reciprocals. The only exception there is tangent and cotangent are both cofunctions and reciprocals. But otherwise, again, it's secant and cosecant that are cofunctions. And the way that works is, as long as the two angles add up to 90, then they will be equal. So if cosecant is 19 degrees, then secant would be 90 minus 19. And so we end up with secant of 71 degrees is the same as the cosecant of 19 degrees. This one is a little bit different since we have the sine of theta plus 87 degrees. Again, the cofunction for the sine is the cosine, and so we do 90 minus the theta plus 87. And so we end up with that sine of theta plus 87 equals the cosine. We do 90 minus the 87, we get 3, and then we still have the minus theta there. So sine of theta plus 87 equals cosine of 3 minus theta. So for number 5, we continue our work with cofunctions. So we have a tangent equals a cotangent. That works so long as the angles are complementary. So 3 theta plus the 50 plus the theta plus 18 would have to equal 90 in order for that tangent to equal that cotangent. So we end up with 4 theta plus 68 equals 90. Subtracting the 68 from both sides gives us 4 theta equals 22. Divide by 4, and theta equals 5.5. And in this case, remember, we're just looking for the solution to the equation, not necessarily the angle measures. So we do know theta is 5.5. That's all we need. For number 6, we want to find the exact trig function value for secant of negative 2,655. So the very first thing we need to do is find a coterminal angle for negative 2,655 that's between 0 and 360 degrees, so we can more easily pinpoint exactly what we're dealing with. So negative 2,655, in order to get that to be positive, we would have to add a full 8 revolutions, and when we do that, we would see that we come up with a total of 225 degrees. So 225 degrees is in the third quadrant, so the secant would be negative in the third quadrant. 225 degrees would have a reference angle of 45 degrees, again because that's 225 minus 180. So we're 45 degrees past 180, so that reference angle would be 45 degrees. And so we need that 45, 45, 90 triangle. Hopefully you haven't forgotten how to do that one. Again, shortest sides that work there are square root of 1. And if we are looking at the secant, secant is the reciprocal for the cosine, so it's hypotenuse over adjacent. So that would be the square root of 2, and specifically negative square root of 2, since we are in the third quadrant, and again we can ignore the fact that it's over 1 because it's a 1. So just the square root of 2 for the secant, or negative square root of 2 I should say, for the exact value of the secant of negative 2,655. For number 7, we're looking at kind of the same idea, finding the exact value of the tangent of 1,230. So first of all, we need to subtract from the 1,230 in order to get that to be between 0 and 360. In this case, 1230 minus 1080, which would be 3 revolutions, gives us our coterminal angle of 150 degrees. Now 150 degrees is in the second quadrant. That's only 30 degrees short of 180. So the reference angle we would be using would be 30 degrees. Tangent is negative in the second quadrant. So this would be a negative value for the trig function. Now our reference angle is 30 degrees, so we would need that 30, 60, 90 triangle. You can hopefully still remember how to do that one. Again, if that side is 2, then this is half of that, which is 1. Pythagorean Theorem tells us that that's the square root of 3. So tangent of our 30 degrees, so working from the 30 degree angle, it's opposite over adjacent, so 1 over the square root of 3. But we'd have to rationalize that, so square root of 3 over 3. And of course, like I said, negative because it's in the second quadrant, and tangent is negative in the second quadrant. Moving on to finding the cosine of 960 degrees. Again, for this, we would have to find, again, the coterminal angle. So we do 960 minus 720. That gives us 240 degrees. 240 degrees is in the third quadrant. That is 240 minus 180 is 60. So our reference angle is 60 degrees. We've gone 60 degrees past 180. So that's our reference angle. So again, we'll need that 30, 60, 90 triangle. I'll just draw it over again, even though we just did it. So that's 2, that's 1, that's the square root of 3. Cosine in the third quadrant would be negative. So Cosine of 960 would equal a negative number because we're in the third quadrant where cosine is negative. And our reference angle is 60 degrees. So the adjacent over the hypotenuse there would just be 1 over 2. So cosine of 960 is exactly negative 1/2. For number 9, we're finding the values of theta between 0 and 360 that would make the secant equal negative square root of 2. Since it is a negative square root of 2, again, it would have to be based off the 45, 45, 90 triangle. Again, secant is hypotenuse over adjacent. So, of course, it has to be the 45-degree reference angle. However, we're looking at a negative square root of 2. So, of course, a 45-degree reference angle, or 45 degrees would be a positive square root of 2, so we don't want that. Secant is based on x, so it would be negative in the second and the third quadrants. So we're looking at 45-degree reference angles in the second and third quadrants. So 45 degrees short of 180 and 45 degrees past 180 is what we're looking at there. And so we end up with 225 degrees and 135 degrees. So those are the two angle measures that would give you exactly negative square root of 2 for the secant. Here we're looking at the cosine being the square root of 3 over 2. Again, hopefully we can recognize then that that has to come from the 30, 60, 90 triangle. Again, with the 2, the 1, and the square root of 3. So the square root of 3 over 2 from the cosine, so that has to be adjacent over hypotenuse, so we'd be working from the 30-degree angle. Now it is the positive cosine, so 30 degrees would work. Cosine is based on x, so cosine is also positive in the fourth quadrant. The 30-degree reference angle in the fourth quadrant is 30 degrees short of 360. So we'll be looking at 330 degrees. So there are the two values there, really the 30 degrees and the 330 degrees. For number 11, we will use the calculator to find the value. However, it's a cosecant, so you have to recall that cosecant of some angle theta equals 1 over the sine of that angle theta. Since we have the sine button on our calculator, we will do 1 over the sine of 7 degrees 49 minutes. And let's see, they do set around to 7 decimal places. So it's approximately 7.3527377. And so that would be it for the cosecant of 7 degrees 49 minutes. For number 12, we are looking at finding a value between 0 and 90 that would give us the tangent of that decimal. It's a tangent which we have on the calculator, so we just do really the inverse tangent of both sides of that equation. And again, on the left side, the tangent, inverse tangent, just gets rid of the tangent, so we're left with theta. And on the right side, that inverse tangent of that decimal will give us our answer. And so the angle is approximately, squiggle that in there, 42.0023318 degrees. Here we'll do the same thing for number 13, finding the angle that will give us that cosecant. The difficult thing here is that we don't have a cosecant button. However, you can recall that cosecant of some value theta is equal to 1 over the sine of that theta. So in this case, the 1.5 and whatever else is going to equal 1 over the sine of theta. Now the problem is we don't want the sine of theta on the bottom, so we flip that over we have 1 over 1.5 equals the sine of theta. So the inverse sine of that 1 over 1.5, and again, make sure you use the whole digits there. So inverse sine of the 1 over 1.566299 will give us our angle measure. So in this case, that theta is approximately 39.6785662 degrees. Next we have our grade resistance question, and you can kind of see the formula in here. Unfortunate spacing there, but it's actually F equals W times the sine of theta, where F is the grade resistance, W is the weight of the vehicle, and theta is the angle of the hill. In this case, they want us to find the grade resistance to the nearest pound of a 1,500 pound car traveling downhill on a grade of, or on a 4-degree grade. So notice there that would be a -4 degrees since they're going downhill, so don't make that mistake. So really here we just plug in the 1,500 and the -4 degrees, and really type that into the calculator, and that will give us the answer that we're looking for, the grade resistance. So the grade resistance in this case is -104 oh no, they want nearest pound, so -105. I get -104.6, so to the nearest pound, -105. For number 15, we're going to solve the right triangle, which means we find the 3 missing pieces, other than the 3 that they give us. Again, highly recommend starting with a sketch. Does not have to be to scale. I wouldn't recommend necessarily trying to get it to scale, other than the right angle should look fairly close. So given information on the triangle, side A is 3.4 centimeters. We talked earlier, remember side A is opposite angle A. Side B is 2.2 centimeters. And so what we would need to do here is use the Pythagorean Theorem. So 2.2 squared plus 3.4 squared would equal side C squared in order to find the length of side C. So in this case, C equals the square root of 16.4, which I suppose if I'm going to round that like they did, that would be approximately 4.0 centimeters. Now in order to find the angles, again I want to avoid using that length for side C because I had to round it. So say for example if I want to find the measure of angle A, I need to write a trig equation and then solve for angle A. Since I have from angle A, I have the opposite and adjacent angles, I would write a tangent equation. So the tangent of angle A equals 3.4 over 2.2. And so I do the inverse tangent of 3.4 over 2.2 in order to find the value of that angle. And that turns out to be about 57.1 degrees. Now I mentioned I didn't want to use C because I rounded it. That would introduce more error into the process. However, for finding angle B, it is okay to do 90 minus the 57.1 degrees because subtraction cannot introduce any more error than you already have or that you would get from any other calculation. And so we just get our value by doing that subtraction because we know those two angles have to be complementary. So angle B is approximately 32.9 degrees. 16 may see the same, but notice the big difference here is that they do give us an angle and a side, and really I guess an angle besides the 90-degree angle. They tell us that angle A is 18 degrees and 37 minutes. Remember, I'm not worrying about trying to draw this to scale. I just want pieces in the right places. So if C is 289 feet, that would be here. and so I need to find the other angle B and the other two sides, A and B. The other angle B would be simple enough. Angle B would equal 90 degrees minus the 18 degrees and 37 minutes. So B turns out to be 71 degrees and 23 minutes. And again, that's not really an approximation, it's just as accurate as the measure for angle A. Finding the sides A and B, since I only have one side so far, I cannot use the Pythagorean Theorem, so I have to use a trig equation in order to find one of those two sides. Let's just say I want to find side B first. Looking at that, I know the hypotenuse, and I'm actually work from angle A here. So side B is adjacent, and then I know the hypotenuse. So I'm going to do a cosine of 18 degrees 37 minutes. That's going to equal the side I want, B, over the hypotenuse, 289. So I would just multiply both sides of the equation by 289. So 289 times that cosine of 18 degrees 37 minutes would equal B. So B turns out to be approximately 273.9 feet. And we could do the same sort of process for finding A. Now A is opposite the 18 degrees 37 minutes. So I would set up a sine equation. So sine of the 18 degrees 37 minutes would equal side A over the hypotenuse 289. So again, I would just multiply 289 by the sine of 18 degrees 37 minutes. That will equal my A. And so A is approximately 92.3 degrees. And now we get into solving triangles with these types of situations. So for 17, on a sunny day, a tree and its shadow form the sides of a right triangle. If the hypotenuse is 35 meters long and the tree is 28 meters tall, how long is the shadow? So we want to find this side. So we have two of the three sides of a right triangle, which means we can use the Pythagorean Theorem in order to find the missing side. So we'd set up the equation like this: x squared plus 28 squared, those being the two legs, equal to 35 squared. So that is really x squared plus 784 equals 1,225. Subtract the 784 from the 1,225, gives that x squared is 441. So we square root both sides of that equation to get the value of x. Of course, we don't want to tell someone that the height or the length of the shadow is the square root of 441 meters. In this case, it actually turns out to be exactly 21 meters. For number 18, again, we'd also need a ABC right triangle. So a tunnel is to be dug from point A to point B. Both A and B are visible from point C. If AC is 150 miles and BC is 319 miles, and if angle C is 90 degrees, find the measure of angle B. So in this case we want the angle, so I need to write a trig equation, and determining which trig equation I want to use, I look at the sides that I have. So from angle B I have the opposite side and the adjacent side. So opposite and adjacent, that's used by the tangent. So tangent of angle B would equal the opposite side 150 over the adjacent side 319. This is where we need our inverse trig function. So the inverse trig function, or inverse tangent really, of 150 over 319 would equal angle B. And so B turns out to be approximately 25.2 degrees. For number 19, again we'll need a triangle. So we have a boat on the river below the dam. So I'm going to call this B for the boat, A for the top of the dam, and C being the 90-degree angle. It says the angle of elevation to the top of the dam is 22 degrees 21 minutes. So that would be this angle here. And the dam is 2,407 feet above the level of the river. Let's see, so that was 2,407 feet above the river. Now, the question they want us to answer is how far is the boat from the base of the dam? So that would technically be side A. So we'll just use A for that unknown value. Again, we don't have two of the three sides of the triangle, so we need to use a trig equation in order to find the missing side. Looking at the angle that I'll be working from, angle B, the 2,407 is the opposite side and the A is the adjacent side. So the trig function that uses opposite and adjacent, of course, is tangent. So tangent of angle B, which is 22 degrees and 21 minutes, equals the ratio of the opposite side, 2,407, over the adjacent side, A. Now in this case, what we'll do is we'll actually multiply both sides of the equation by A. That'll cancel the A's on the right. And then we'll follow that up by dividing both sides by the tangent. I'm just going to put tangent. Well, I'll do 22 degrees, 21 minutes. Let's divide that by the tangent, 22 degrees, 21 minutes. So that side A is equal to 2,407 divided by the tangent, 22 degrees, 21 minutes. So we'll have the calculator figure that out for us. And so to the nearest foot, the value of A, I should approximate that, value of A is 5,854 feet to the nearest foot. So for number 20, we've got the vertical tower. It's 355 feet above the surface of the earth. Angle of depression to the doghouse is 27 degrees 12 minutes. The question is, how far is it from the doghouse to the foot of the tower? Now, the problem a lot of people have with this is they want to make this angle here the angle of depression, but it's actually this angle here.
Mr. Johnson?
And so the actual angle we're looking at here that they give us is the 27 degrees 12 minutes. So that's really the angle of depression. Now, I can use that angle of depression to find this angle here, really, because the two together make a 90-degree angle. So I could do that, or the thing is that 27 degrees 12 minutes would be the same as the angle of elevation from the doghouse. So with a weirder angle with the degrees and minutes on this one, I would probably just use the 27 degrees 12 minutes as the angle of elevation. And again, part of the reason I can do that is because these two lines, this line straight out from the tower and the ground, are both horizontal, so those would be parallel. So these two alternate interior angles would be congruent. From there, they want to know how far it is from the doghouse to the foot of the tower. So I'll just call that side A. So I can set up a trig equation. And so I have that 27 degrees 12 minutes as my angle of elevation. So again, working from this angle. And I know the opposite side, and I want to find the adjacent. So it would be a tangent equation. So tangent of 27 degrees 12 minutes equals the opposite side 355 over the adjacent side A. Now that gets to be a little bit more of a problem than we had before, but we can deal with it pretty easily by multiplying both sides of the equation by A. That gets the A out of the denominator. And then I really divide both sides by the tangent of 27 degrees 12 minutes. So again, with nothing really over here, 27 degrees 12 minutes. So that value of A, if I bring that back up here, equals 355 over that tangent of 27 degrees 12 minutes. So let the calculator figure that out for us. And they wanted this answer to the hundredths place, so I get 690.76 feet for the distance from the doghouse to the base of the tower. Thanks for watching, and hopefully that helped.